Say we want to find the steady state voltage across a component in the circuit. Say it's these components here, that is voltage VAC. We can use Kirchoff's current law to help us find that quantity. Kirchoff's current law tells us that the currents into a node, and we'll look at node A for this example, the currents into the node must be equal to the currents leaving the node. We're also going to use Ohm's law to help us find expressions for each of these currents. So Ohm's law tells us that a current is simply the ratio of the voltage across the resistance. For I1, we can find an expression. The voltage across the resistance there is going to be 10 volts from the battery minus whatever voltage we have left at point A. This 10 volts here is implicitly with reference to ground, so we will reference voltage A to ground as well, and that's where point C is connected. So we've got 10 volts minus VAC is the voltage across the resistor. The resistance is 100 ohms. For I2, things look slightly scary at first because we have an inductor, but remember at steady state, because here we have a battery, which is a DC source, at steady state we only care about the DC signals, and so the DC impedance for an inductor, remember, is 0 ohms. That looks just like a wire. We can ignore the inductor. What's left? Only this resistor here. So I2 is the voltage across that resistor, which is VBC, or actually VAC, since there's no voltage drop across the inductor, divided by, again, 100 ohms. Finally, we've got current I3. This is VAC divided by 100 plus 150 ohms. So we're going to take these definitions here, I1, I2, I3, and we will put them into our equation that we got from Kirchoff's current law, and we get something that looks like this. We'll start with the I1 expression, 10 volts minus VAC over 100, and this must be equal to I2, which is VAC over 100, plus I3, which is VAC over 250. And now we can rearrange this equation to get VAC onto one side. We're left with 10 volts over 100 is equal to 2 VAC over 100 plus VAC over 250. If we rearrange to make VAC the subject, we get VAC is equal to the ratio 10 over 2.4, which is in old money is a little bit larger than 4.16 volts.